Okay, so this part here, now when you want to find the plane 3 equation, right, what you need to do is actually, remember, this is in Cartesian form, right? Cartesian form. So what we need to do is actually group the coefficient of x, y, and z together. So for part 3 here, what you need to do is put it down as okay, part 3 here. Group the x, y, z. So 2 minus kx. Can I just keep step here? So 2 minus kx plus 1 minus plus 2ky. Okay. Then plus 3 plus kz. After which you have a plus 2 minus 2k minus 1 equals to 0. Okay, so I just expanded and I just grouped the coefficient of x, y, z together. Is that okay? Is it about okay? Is this about okay? Changing, just group the x, y, z together. The rationale being is because you want to change this to scalar product form. Now, scalar product form is a very powerful form. We like it because we have the normal and we know what sort of distance it is from the origin. Okay, so this case here, once this is done, what you need to do is actually write down P3 is equals to R dot 2 minus K1 plus 2K3 plus K, and this will be 2K plus 1. This is your P3, okay? So this is your P3, the normal. Anyone issue that? So for the subsequent part, what you could do is the otherwise one, which is this otherwise, right? Find the equation of line L and this line together, okay? So you can actually do that. You have a line equation, you have the point 2, 3, 4, it also is, you have, so between a line and a point, the otherwise, you can actually solve this by using line and point, which is actually line and point, which is page 21, question 1. Page 21, the top left corner. Okay, so page 21, question 1. So you can actually do that. Now, what I'm trying to say is, if you do not do this right, you need practice. You can't start flipping in exam. You can't. You need to know what to do, how to do it. Okay, I've already explained it before, so you go back and rewatch it. You really, really have to practice. If you don't practice every week, 2 hours is not enough. Okay, so I need to explain a bit to you how this works. Okay, so the thing is, explain why line L lies on P3. Lie on P3. How do you show that line L is on P3? Okay, first, meaning to say you need to show L satisfy P3, okay, for any constant K. So what I'm going to do is I'm going to sub line L. This is L, right? For this one, show L is on P3, sub L into left-hand side of P3. You want to show that it always satisfies the plane 3. If it always satisfies the plane 3, so regardless of the value K, line L is always on P3. Later I'll visualize it for you, but I'm trying to do this without visualizing it first because you should be, because you can't, you have to visualize yourself in exam. Later I'll use the software and you understand it, okay? You need to be able to see it visually later. So I'll show you later. So this case here, sub L, we just sub L, this L here, this whole L here, into this left hand side. So P3, R is 0, 1, 0 plus lambda minus 1 minus 1, 1, 2 minus k, 1 plus 2k, 3 plus k. Okay, so this part here we get is 0 plus 1 plus 2k plus 0 plus lambda. This will be minus 2 minus k minus 1 plus 2k plus 3 plus k. Okay, so remember how I manipulate it because this one multiply with this one. This one multiply with this one. So this one is 3 plus k. Okay, so this part will be 1 plus 2k. The one on the right will be 0. Okay, so it always satisfies the plane equation. Always. So you can just write, hence line is okay. There you go.